Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important question, important topic that is from the time dependent perturbation theory. According to your core syllabus of CSIR, time dependent perturbation theory, Fermi golden rule and selection rules are there. So, these topics they are quoting. So, here what we are discussing in the time dependent perturbation theory, first briefly I am telling to you. So, for your previous knowledge purpose I am teaching to you. Once you have to see, first we have to calculate the first order transition amplitude for a time dependent perturbation theory. So, now later you are going to calculate the first order transition probability for the time dependent perturbation theory. So, this transition probability we have to apply to the two systems. One is the constant perturbation, that is the time independent perturbation. The latter you have to apply the harmonic perturbation, that is the example of the started particle interacting with the electromagnetic field. Clear? So, these two things are there. Maybe one more video I will teach to you under the constant perturbation. I will give to one question to you. So, whatever it may be. So, the two questions I am giving to you in a time dependent perturbation theory only. So, later one more topic is there, that is the transition rate per unit time. So, that is going to become as the Fermi golden rule. How we have to apply the selection rules, those things we have to learn in this time dependent perturbation theory. This is the brief idea about the time dependent perturbation theory. So, one question came, not only one question, in every examination people are asking based on the time dependent perturbation theory. So, this is the very important topic in the core quantum mechanics syllabus. In CSIR December 2016, there was a question, a particle of charge q in one dimension is in a simple harmonic potential with angular frequency is equal to omega. It is subjected to a time dependent electric field, is subjected to a time dependent electric field E of t is equal to a e to the power of minus t by tau. E of t is equal to a e to the power of minus t by tau whole square, where a and tau are positive constants, and you have to take the condition omega tau is greater than 1, you able to take, this is the condition. If in the distant past t tends to infinite, if the distant past t tends to minus infinite, you have to take so in the distant past t tends to minus infinite, the particle was in the ground state. So, the particle was in the ground state means E0 is equal to h cut omega by 2. So, this is the linear harmonic oscillator because it is a simple harmonic potential, because for the simple harmonic potential, if you have to consider as a simple harmonic potential, you are going to take the how much energy for the ground state. So, for ground state is equal to h cut omega by 2. So, now you have to find out the probability, that we need to calculate the probability that it will be in the first excited state. So, what is the first excited state? E1 is equal to 3 by 2 h cut omega. So, when t first excited state, when t is equal to minus infinite, when t is equal to plus infinite, you have to write it is you are going to get it as a first excited state, the particle is there. Clear? So, this is also same simple harmonic potential. What we need to calculate? So, the probability that will be in the first excited state is proportional to, they are asking the probability, we need to calculate the probability PIF is directly proportional to how much quantity. So, they are asking. So, exponential of minus 1 by 2 into tau omega whole square plus 1 by 2 into tau omega whole square 0, 1 by omega tau whole square. So, the probability is proportional, they are asking. but you know that so this is the transition probability for time dependent perturbation theory. For time dependent perturbation theory, so the transition probability is directly proportional to, is directly proportional to what? So the modulus of integral minus infinite to plus infinite, integral minus infinite to plus infinite e to the power of minus t square is divided by tau square into e to the power of I omega km. So I omega km means Fi, you have to write it is omega Fi into t, I omega Fi into t into dt. So whole square, this is the probability of the transition probability. Which one it is? Probability you have to take. So the probability, how we have to write it as the probability you are going to write it. So from this probability what we have to take, now you have to substitute omega Fi is equal to omega Fi is equal to what we have to write it is omega 21. So or omega 10, you have to write it is 10 omega E1 minus E0 is divided by h cut. So this is what? This is a Bohr's angular frequency. Bohr's angular frequency, correct? Which frequency it is? Bohr's angular frequency we have to write. Already we are discussing 3 by 2 h cut omega minus 1 by 2 h cut omega is divided by h cut. 3 by 2 minus 1 by 2 is equal to, we are going to get it as a h cut omega is divided by h cut going to get cancelled. You are going to get it as a omega. So therefore what we have to write here, you have to substitute, so PIF so is directly proportional to integral minus infinite to plus infinite, integral minus infinite to plus infinite exponential of minus t square is divided by tau square into e to the power of I omega into t. So dt modulus whole square you are going to get. So therefore the probability of initial to final integral minus infinite to plus infinite, we have to write it is exponential of minus t square by, so we have to write which one we are going to take it as a, you are going to take it as this one, you have to take so minus t square by tau square plus I omega t into dt we have to write. So modulus whole square, because exponential is there, so that's why I have to bring it e to the power of a into e to the power of b is equal to e to the power of a plus b I have to write. Now I am rearranging this term. How we able to rearrange? You have to say the probability of is equal to integral minus infinite to plus infinite, integral minus infinite to plus infinite exponential of minus t square by tau square a plus I omega t into dt modulus whole square is there. Now I have to take the integral part. This one you have to consider as a I. After some time we have to calculate the I square. First integration part I have to consider. So this integration part I have to take it as a I is equal to integral minus infinite to plus infinite exponential of which one we have to take. So exponential of minus 1 by tau square you have to take the common. So what is going to happen? Into minus 1 by tau square you have to take the common. You able to take it as a, so t square plus you are going to get minus 1 by tau square you have to take the common. So t square minus it will come. So minus I omega t tau square you are going to get. So I omega t tau square. I am rearranging this expression. I omega tau square by 2 I omega tau square by 2 whole square minus I omega tau square whole square is by 2 whole square you have to take. So that is the bracket close into dt. I am rearranging this expression. Clear? So you have to add this and you will get that. So this one you have to take a minus b whole square is there. So that's why again you have to rearrange this expression. Integral minus infinite to plus infinite exponential of minus 1 by tau square into. So we have to take here exponential of which one we have to write, it is exponential of minus 1 by tau square into, we have to write it is so e to the power of I square, that is minus 1 it will come. So minus into minus plus you are going to get it. So therefore omega square tau to the power of 4 is divided by 4 you are going to get. So tau to the power of 4 is divided by 4 exponential you have to write it is. So that is going to take so here you have to write it is you are going to apply here. So what will happen, you have to see into, so you are going to take, this is the exponential, so into we have to take here, so plus you are going to get, so t minus I omega tau square is divided by 2, so you able to get into dt. Clear? So you are going to take that one. So tau to the power of 4 you are going to get, so tau to the power of 4, so tau square you are going to get. So therefore what we have to write, you are going to bring this side, I is equal to, so I is equal to exponential of so minus omega square tau square is divided by 4, you have to going to take it as a, because it is the constant term, because there is no t here, so that's why you have to bring outside. Integral minus infinite to plus infinite, the rest of the thing you have to write here, exponential of t minus I omega tau square is divided by 2, so into dt you able to write it. Is clear? So now this I you have to substitute there in the transition probability. So the transition probability you have to substitute. How we have to substitute? The probability of IF is directly proportional to which one we have to take it as a exponential of minus tau square omega square is divided by 4 into integral minus infinite to plus infinite exponential of t minus I omega by 2 tau square. So I omega by 2 tau square into dt, so that modulus square you are going to get it. Clear? So that is the value you have to write it, t minus I omega tau square by 2. So that is the b value. Now you have to bring, this is the constant you have to bring outside. So that is the thing you have to write it is, therefore PIF is proportional to what we have to write, exponential of, I am bringing outside, so minus tau square omega square by 4, so you able to take it as a 2, so whole square is equal to 2 1 ja 2 2 ja. So now proportional I am taking, that's why I have to take it as a, the constant term I am taking, entire the thing are there. So therefore PIF is proportional to exponential of which one we have to write, it is minus 1 by 2 into omega tau whole square it will come. So this is your answer. So based on that, so you have to see the options, which option is correct you have to check it. So which option is correct you have to see. So minus 1 by 2 into omega, so tau whole square, option A is correct. Option B is plus is there, is not correct. This one is 0 and this one 1 by omega tau whole square, that is also not correct. Clear? So like this you have to do in your competitive examination. This is the question belongs to the time dependent perturbation theory. This question belongs to time dependent perturbation theory, time dependent perturbation theory. Clear? So from the time dependent perturbation theory you have to do the questions like this you have to do. If you really likes my teaching, we started the online coaching, that is the CSIR and GATE physics online coaching we started. We have one app from your Android mobile phone. So you take that app, that is the Quantum Online Academy app is there. We are offering the physics content for JL, DL, polytechnic lecture or assistant professor, whatever it may be. Once you have to go through the app, and if you have any doubt, technical problem, you have to call me 9908437460. This is my number. So my YouTube channel is Quantum Online Academy channel. So already you are listening. So my classes in YouTube. So like this we will deliver the lecture. So we teach the theory, the latter we are practicing the questions also in our app. So once you have to take, our courses will display like this: CSIR and GATE physics, JL physics and DL physics, like this our courses will display. Till now we are finishing the 4 papers we are finishing. Right now individual papers also you will get it available. From the first paper is mathematical methods of physics, the second one is the classical mechanics, so the third one is electromagnetic theory, so the fourth one is quantum mechanics. So these 4 papers till now available, the recorded classes are. So now the quantum mechanics, almost core syllabus of quantum mechanics is core syllabus of CSIR. CSIR core syllabus we are finishing. Core CSIR syllabus, quantum mechanics syllabus we are finishing. So now advanced part is there. There is everyday live and recorded classes are available. If you want to join quantum mechanics advanced classes, you are going to listen lively. So once we will finish this quantum mechanics classes, already recorded mode only you want to listen, because 5 more papers are there. The statistical mechanics and electromagnetic theory is finished, electronics, SSP, atomic and molecular physics and nuclear physics. So these 5 papers need to take the live and recorded classes. Once entire the syllabus is finished, I won't reduce the fees also. So if you really likes, now I will generate and you negotiate with me, generate the coupon, right? Then you have to join. First you call me and confirm and join the courses. So learn the subject with loving kindness. You have to learn the subject. So then only you able to success in your competitive examination. Thank you so much. So like these videos, I will upload from each and every topic one video I will upload for the corresponding to the CSIR questions. So whatever the questions are there, so those questions I will upload in our YouTube channel also. Listen in YouTube channel and enjoy my teaching. So thank you so much. Please share and like and subscribe our YouTube channel. Thank you.